the dataset which I'm going to use is the standard iris dataset. And here is the dataset which I'm going to use. This dataset has 5 columns. This ID is the index column, and the other 4 features are sepal length, sepal width, petal length, and petal width. And the 5th column is the labels column. So we need to import the required modules, and first module is NumPy. Next module is matplotlib, which is used for visualizing the variances. Next is pandas for loading the dataset. Next module is the PCA module from Scikit-learn. Yeah, let's load the dataset. So iris. So are you able to see my terminal?
Yes.
Okay. So let's look at the first 5 rows of the terminal data. So these are the first 5 rows of terminal. And just see some of the descriptive statistics of the data. So here we can see each column has some statistics, mean, standard deviation, and 25th, 50, and 75th percentiles. Yeah. Then we just separate into. Okay, okay. Features and labels. Species columns contains the labels of type of flower, iris setosa versicolor. So I'm just extracting it. Yeah. So now this has only the features which we are going to use. So just instantiate the PCA variable. Okay, I'll just comment later. First we fit the data to the variable. So the values. Okay, now we have applied PCA transformations like the step 1, step 2, step 3, and step 4, which was explained by Radha, to the available data set. And it has some default parameters in like the random state and the iterative power and the decomposition method. So we see the number of components found in the existing data. We can see the number of components found in the existing data using the variable and components. And the explained variance, like there are 4 components, and the amount of variance explained by each component can be viewed using this variable. Most of the time it's like difficult to visualize numbers, so I'll just make a bar plot of this. Yeah, this is the explained variance by each component. This is first component, and this is second, third, and fourth. Okay. Then so explain variance ratio is the amount of variance in the amount of total variance explained by each of the component. Again, we'll visualize this. We'll just make a scatter plot of this. Yeah, this is scatter plot. This is the total amount of variance which is explained by the first component, second component, third. We can also view the amount of variance explained by cumulative amount of variance explained by each component by using this scheme. Okay, you can see the first component explains about roughly 91-92% of variance, and the second component explains around 96-97% of the total variance, third component and 99%, and just the fourth component explains complete variance in the data. If you want to view the covariance matrix of the data, you can view using this command. Yeah, this is the covariance matrix of the above given data. Okay, these are the four steps which was explained by Radha. Fitting the data and computing eigenvectors, eigenvalues, making a covariance matrix, and then just viewing the results. The fifth step is we need to apply the data, like we need to apply the results to our data and get a final data set. So I'll just plot it again. This, yeah. Yeah. Okay, here we can see that this plot shows these dots show the amount of variance explained by each of the component. You can see that this explains around 97% of the total variance in the data set. So it's better we take two components in encoding our data and transform the data. Okay, so PCA also provides a transform function which can be used to transform the original data set and encode into in our final data set. Okay, whenever we apply the transform function, we get the transform data set, and this is our transform data set. PCA.transform x.values. Okay, we know that we want only the first two components value in modifying the final data set. So we just run instantiate the PCA variable, but this time we initialize with n components equal to 2. This says that this says to the algorithm that just keep the first two components and discard the other two components. PCA then PCA.fet, we just pass the original data set. Okay, and PCA.transform. So yeah, now you can see that there are only two columns in the transform data set. At first we had four columns of iris data set, and now it was compressed and encoded into these two columns such that it has maximum variance, and variance of the data is explained maximally with minimum. So and and also there's a website called setosa.io and principal component analysis, which explains the idea of principal component analysis with some graphics and with nice graphs. So this is a 2D example. So here you can see 5 points in the data set and the components. This is the x component and this is the y component. So, and after applying the PCA algorithm to this data set, the data set which we are going to get from PCA is looks similar to this, which is the red line represents the first component and the green line represents the second component. So this is interactive. These are interactive graphs, so you can change the graphs and you can see how these components and principles are varying. You can see that how this is varying whenever I change a point. So this is the amount of variance in principal component 2, and this is the amount of variance in principal component 3. There's also a 3D visualization of this. You can see here. I'll just reset it. So this is the actual dataset, and this blue, red, and green are the three axes which are present here. So yeah, these are the amount of variance which are explained by the first three components. So we can just modify or just tweak this data and so and see the amount of variance. So here now I have arranged data in such a way that it's spread across the y-axis and spread minimal across x and z-axis. So that is the reason we are seeing there's a lot of variance in the second component and less variance in the first and third components. And you can tweak these parameters and you can see how the data is moving. So this is another example. This is another example where there's a data set eating in the US, UK, and there are 17 features. We have to encode this into 3 features. That's it, sir.